Dean of the University situated at Guntur, Andhra Pradesh. I, Dr. Shubhalakshmi Sengupta, scientist in the Department of Sciences and Humanities, on behalf of the organizing committee comprising of the Environmental Science Forum of Sciences and Humanities Department and Internal Quality Assurance Cell BFSTR, would like to request Dr. Desikan, convener and associate dean of IQAC, to deliver his welcome message. Sir,
Thank you,
over
madam.
to you.
Thank you, madam, for your kind introduction. Ladies and gentlemen, very pleasant morning to all of you. I welcome all of you on behalf of Environmental Science Forum and Internal Quality Assurance Cell, Vinyans Foundation for Science, Technology and Research, located at Vadlamudi, Guntur district in Andhra Pradesh. Let us save together our environment from getting poisoned with pollution. Let us create more awareness on National Pollution Control Day and about the pollution control to save the earth and save the nation. With this quote, I welcome Dr. Distinguished Speaker, Professor Anjanelu Sir, former Director, Jackson State University, and former Director of JNTU Hyderabad. And I also welcome Dean IQAC, Dr. Ramakrishna, and HOD SNH, Professor Srinivasu, and Chemistry Division Head, Professor Prabhakar Rao, and other participants and my dear students. This is the national webinar on, Sir is going to give the talk on air pollution and air quality management in the occasion of this National Pollution Control Day 2020. The National Pollution Control Day is observed in the memory of the people who were lost their lives in the Bhopal gas incident and Bhopal gas calamity in the year of 1984 because of methyl isocyanate poisonous gas, which is one of the most horrific incident and industrial pollution disasters in 1984. Nearly 3,787 lives and people were lost in the Bhopal gas tragedy in the year of 1984. So I think this is about the welcome remarks, also the introductory information about this webinar. So I would say the webinar has opened, and I strongly believe all the participants will have the good take-home message and happy learning. Thank you. So with this introduction, I welcome Professor N. Srinivasu, HOD SNH, to give the opening remarks. Sir, please.
Good morning, sir. Thank you for your introduction. Just I speak about this. I am the head of the Department of Science and Humanities. Actually, our department is categorized into 4 divisions, and our people around most of the faculty are doctorates, and it is they published very good journal papers, including JACS also. Some papers are there. And regarding the university, our university is NIRF ranking, it is 100. And our university a NAC A grade, and our people are working together for research. Now it is good condition. Now they improved. And regarding the National Environmental Day today, the pollution, that is the major problem throughout the world. Particularly, some of the pollutants, particularly toxic elements, lead, arsenic, all these things are there. In addition to that, general chemical pollution as well as radioactive pollution, so many things it should be happening, and particularly plastic waste. That is the disposal of the waste is the very important there. I read the books of the Anjanelu sir earlier. It's a good. You have. I saw so many books of you. It is a privilege to today you are be with us, and I am welcome. I am very thankful and grateful to you, sir, throughout my life also. Thank you, sir.
Thank you, sir, Professor Srinivasu. Now I welcome Professor Prabhakar Rao, Division Head, Chemistry Division, Science and Department of Science and Humanity. Sir, please give the opening remarks.
So thank you. Good morning to one and all. First of all, it gives me immense pleasure to be part of this event. And I must congratulate to the team of IQAC and Environment Science Forum of VFSTR for organizing this event. In fact, concern about environment is very important. Keeping in mind, the governments also put up the subject on environment science in all degrees. In fact, it's known that especially the air pollution is very concern for countries like India, which is a highly populated country. We are also seeing the consequences of the air pollution in cities like Mumbai, Delhi, and other major cities also. So I request all the researchers should focus on how to purify air, even though I'm also working on purifying of carbon dioxide from other gases, one of my research area also. With this remark, I must thank the organizing committee for giving me this opportunity. Thank you, one and all.
Thank you, sir. Now I request Professor M. Ramakrishna, Dean IQAC, to give the opening remarks. Sir, are you available? Okay, it's fine. So I think sorry is not available. Okay, we'll go to the next person. I request Professor Dr. M.V.K. Srivani to read out the profile of the speaker. Madam?
Sir, can you hear me, sir?
Yes, please go ahead.
Good morning to all. I, Dr. M.V.K. Srivani, Associate Professor from the Department of Sciences and Humanities, here to read the profile of Dr. Anjaneyulu Eramilli. Dr. Anjaneyulu Eramilli worked as professor in the Department of Chemistry, Environment, and directed Trent Lord Geospatial and Visualization Research Center at Jackson State University, Mississippi, United States of America. He also worked as professor and head center for environment from 1990 to 2002 and director Institute of Science and Technologies from 2002 to 2005 at JN2 Hyderabad, India. During his stay at Jackson State University, he worked as principal investigator for National Oceanic and Atmospheric Administration, sponsored program on atmospheric dispersion modeling of Gulf Coast, National Science Foundation sponsored program on collaborative research CI team with Purdue University and Department of Defense sponsored program on high performance competition for development of novel nanomaterials. He has published number of papers on simulation of mesoscale coastal circulation of Gulf Coast for air pollution dispersion by integrating weather research and forecasting. He's built smoke community multi-scale air quality modeling. 46 students received PhD degrees under his supervision, and he published more than 150 research papers in peer-reviewed journals, which have more than 3,500 citations with H-index of 30. He presented many papers at various international conferences. He has authored a number of books on introduction to nanoscience and technologies in 2017, energy resources utilization and technologies in 2012, environmental impact assessment methodologies in 2011, introduction to environmental science in 2005, hazardous waste management, air pollution and control technologies in 2018. He is a fellow of Royal Society of Chemistry, London, life member of American Chemical Society and Indian Science Congress. Sir, we are very proud and happy to have you on this occasion. Thank you. Hello.
Thank you, madam. So for
Thank
your thank you.
Thank
So
you.
now actually I hand over to sir. I request Professor Anjaneyulu sir give the valuable talk on the air pollution and control. Sir, please over to you. Thank you, sir. We can coordinate with him. Ask him to. I think we can. Sir, you can share your screen about your presentation. Then everyone can see that the slide. Share the screen. Yeah, so you are the host now. You can share your screen. Yeah, it's coming. Yes, sir, it is visible. Thank you, sir. It's over to you. Yeah. So your voice is not audible. You can unmute. Anjaneya sir, your voice is not audible still. You unmute. The left corner, that unmute button is there, sir. In the Zoom itself, the left corner unmute button is there. Can you please?
Hello?
Yeah, audible, sir. Please.
Okay, thank you.
Thank you, sir.
Good morning to all of you.
Make the slide big size, sir. F5 you press it, then it will become full screen. Then you can, yeah.
Okay.
Yeah, exactly. Yeah, thank you, sir.
Okay,
Please.
everything is okay?
Yes, fine. Please go ahead. Thank you, sir.
Good morning, all of you. This is Professor Anjanelu Yerramelli speaking from Edison, New Jersey, USA. And first of all, I thank all the organizers and Shiva Shankar for giving me this opportunity to address all of you, particularly the faculty of Vigyan University. And though I yet to visit your university, I have a great relation with your university, particularly because I am a Guntur guy. I lived in Guntur 1970 to 1990 as a faculty of Nagarjuna University. And at those times, I used to meet your chairman Rattai Garu very frequently. We used to have a very frequent meetings, and he's a good friend of mine, and I have a great admiration for his entrepreneurship and also his efforts in creating a number of education institutes for providing education to rural people around Guntur. And I know a number of families have benefited by these institutes. And in fact, mine is also, ours is also one family. I used to live in Lakshmipuram, Guntur at the time around 80, and he started Vigyan Little Public School. I have two daughters, both are the first batch students of that Vigyan Little Public School. And they're now settled in America. One is a physician, and the other one is a design engineer working in Merck. And this other thing is your vice chairman is also a contemporary of my daughters, and they studied from LKG to 10th class in that institute, and they cherish a lot of memories. That is why I'm telling all these things. I have a great bonding with Vigyan institutes, Rattai Garu's institutes, and I'm happy that it is ranked A grade and doing extremely well. And this is a very good opportunity for me to interact with all the faculty. And this I'm really choosing a day like this for World Environmental Protection Day is very fortunate to share some of my ideas with you. And today I'm asked to speak on air pollution, air quality management. And you all know air pollution and air quality management are going to become very important issues for many developing and developed countries also, though is a urban phenomena. And many countries are facing severe issues in management of the air quality. And because, as you know, under a corona pandemic, everybody is wearing a mask, going out like that. There may be a day if you do not take care properly in maintenance of the air quality, you have to carry out your oxygen cylinders along with you because the air you breathe, already some situation in Delhi and all that is like that. And so all education institutes should be though yours is a rural university, you should have all the faculty should have the necessary infrastructure and also skills to deal with these challenges going to be faced by the country. And as I see, last year there is a one report, Global Air 2020 report, which says that nearly 17 lakhs people are died due to air pollution in India, next to China. China is 18.5 lakhs they reported. So not only this is the only deaths, and several lakhs of people are affected by air pollution due to causing various ill health to the people. So this is going to be a major issue in the country-wise, and we all know cities like Bombay, Delhi, and Chennai, all metropolitan cities are facing the air pollution problem. And okay.
One second, I'll share the other one.
Okay. Sorry. Okay. So this air pollution issues not only India level, in our Andhra Pradesh level, already National Green Tribunal identified the two cities, Vijayawada and Visakhapatnam, are the major cities which are likely to face air pollution issues. Vijayawada is identified as the 45th position, and Visakhapatnam is the 96th position in the among the pollution city affected cities in country. And so they have advised the government of Andhra Pradesh to take necessary steps to reduce air pollution. And luckily, at present, the Central Pollution Control Board is monitoring a number of traffic corridors in the cities of India, particularly with reference to Hyderabad, Andhra Pradesh. It is monitoring in Vijayawada and also Visakhapatnam. I've shown in that picture where that station is there, and it is providing the data continuously, hourly data and 24 hours data to the website. Somebody who is interested can take that data and use that for modeling. And so this gives the picture how yeah, this is regarding the Visakhapatnam position. I just given a one data of 1 day, typical data, how it you get the data from CPCB, which is jointly works with the Andhra Pradesh Pollution Control Board. And these data are available for waste pollution like PM 2.5 and PM10 and SOx, NOx, and NO2 and carbon monoxide, apart from various meteorological parameters. And so Andhra Pradesh is also facing severe, likely to face the problem due to air pollution, though this is mainly urban phenomena. Wherever we have the urban conglomeration, and this village around that also going to be affected. The biggest problem is the dispersion of these pollutants varies with the atmospheric conditions, and so the people who are around that, which place around those places, though the pollution may come from traffic corridors and industrial corridors, so it will spread around that, and depending upon the meteorological conditions, people will be affected, and their health issues will be coming. So there should be a clear understanding of what is the pollution levels, at what time they are coming, and what are the likely areas to be affected. So these has to be taken into consideration, and there should be a clear picture of so that proper strategies for control of these air pollution effects can be prepared and implemented so that the people are protected. So for this, so here monitoring is one aspect, and which luckily at present it is the Central Pollution Control Board are doing it a number of important sites in various cities, and luckily they're also making available this data, whereas people, researchers and faculty like yours can use this data and develop proper models and see what are the areas likely to be affected, what are the population likely to be affected by these pollutants, what do these pollutants contain, how they are going to affect the health aspects. All these need to be critically studied. There's a requirement, and that will give a clear picture for the decision makers to understand. And I'm in this field last 30 years, as somebody already told, that since 1990, I worked on a World Bank project when I'm JNTU on the monitoring of air pollutants, multi task pollutants, so that online monitoring. So what we have are now seeing the online monitoring data, which we have attempted in 1995 under World Bank program, and so that the data directly comes to the CM's office or other pollution control board office, or anybody who opens that website, they can see that. That is what we have attempted at that time. And so that based on that, we have identified what are the quality of air in different parts of Hyderabad, and how it is changing every day and every week and every in a year, and then prepared maps, decisions for taking necessary steps, and then uh, based on that, we made some health risk assessments. And from there, in 2006, I moved to US, and where I worked on a National Ocean Atmospheric Authority project on climate change and their impact on the air pollution. And my job mainly is to develop decision support systems, particularly when an accident happens in an industry or when an accident happens on a traffic corridor. Because in US, the vehicles carry huge amount of chemicals, and if some chemical breaks down, or if a vehicle breaks down, and those chemicals come into atmosphere, what will be the areas likely to be affected, and to what extent they are going to, we have to prepare maps. There will be first responders. Within an hour, we will get the information that there is an accident, and within next hour, we have to provide next 1 hour what are the areas going to be affected. In coming 24 hours, what are the areas to be affected, to what level these pollutants will be. All these things we have to give in terms of a maps, and so that they prepare necessary the first responders strategies for rehabilitation and necessary prevention operations. So that is the task I have given when I joined in Jackson State University, to development of decision support systems for air pollution disasters, and also develop modeling techniques for studying the climate impact of climate changes on air pollution. So these are the main two talks with which I joined, and we have also established a number of systems. So with this, from last 30 years, I'm involved in air quality monitoring, modeling, and development of decision support systems. That's why I want to share some of my experiences with this, which were done at the international level, so that some of them can be used as a model to start new investigations and new areas can be started. And I know some of you are experts in air pollution. So still I want to give some basic data on air quality, what is air pollution and all that, so that there will be continuity in our discussion. And you can see here in the right side, there is a one slide which gives, can you see that? So, yeah, this slide gives you rather the composition of air, which is around 80% nitrogen and 20% oxygen, and the remaining will be trace gases. And particularly when you say pollution, only the trace gases like ammonia, ozone, carbon monoxide, and sulfur dioxide, particulate matter, and these things are more than the levels prescribed, we call them as pollutants. And so just to have some idea, those who are new to this field, I have given that. That is the clean air. And so when some of these trace gases are more than the levels, we call them air pollution. And particularly when you burn any fuel, you will get the primary pollutants like carbon monoxide, carbon dioxide, sulfur dioxide, oxides of nitrogen, and metal hydrocarbons and particulate matter. And so these will interact with the atmospheric constituents like water and also sunlight, and to produce the secondary pollutants like sulfur trioxide, HNO3 acids, and also ozone, and the ponds and polycyclic aromatic nitrogen compounds, which are very toxic, and carcinogenic compounds. All the secondary pollutants will be generated. So if there are more secondary pollutants, the atmosphere becomes more active, more toxic, and so you have to see that is reduced. And the primary pollutants also, the extent to be reduced either by using proper control systems at the, mostly these are either by the industry or by the automobiles. And so particularly when the particulate matter comes from automobiles, they are of small in size, to PM 2.5 size, 2.5 micrometer size, which are very more dangerous because our respirable system filters up to 10 micrometers, and beyond that, below that, they will allow it to go inside. So these particulate matter go inside and then settle in our lungs. And because when the size of the particle is very small, they absorb other gases, and which will be released into the atmosphere and released into the lungs, and then become more toxic, cause more serious health problems will come. So these are the toxic nature. The toxic nature of the pollutants also vary. Particulates, we have a relative toxicity around 106. Kindly bear with me, I'm giving some fundamentals, and I know some might be experts, but because there are some students and all that, I'm just sharing, giving some examples of this so that the better discussion, you can further discussion, there will be a better understanding. Similarly, NOx around 77% and SOx 28%, and carbon monoxide around 1% weighing factor of the toxicity. So the toxicity varies with the pollutant, and so of all these things, the particulates are more dangerous and should be more control, serious control system should be there for particulates. And coming to the based on the relative toxicity and the World Health Organization has given some standards for various pollutants, and our Indian standards also there. And these are the for sensitive areas, industrial areas, residential areas. They have different sensitive standards were given, and depending upon, because in an industrial area, people will take necessary precaution having some mask and all that. So they have given less, and residential area, sensitive areas like hospitals and all that. So the people are more sensitive, easily affected. So the values will be less. So these are the three areas for different standards are given. And so that anything above these values we call pollution, and we have to, if they are more persistent, like they are available for a long time, so we have to take necessary steps to strategies to prevent one, or to control, to minimize these pollution, air pollution. And these are the critical levels you have given, that is low, moderate, high, and critical levels for different, for industrial and residential. The sulfur dioxide and suspended particulate matters, these values are given, so that if these values exceed and them reach critical values, so immediate steps have to be taken by the control boards and administration. And coming to the particulate matter, as the toxicity is very high, and particulate matter coming from different sources. One is earth excavation, or any excavation with dust or some like that. So they have the main constituents, like there will be about 10 micrometers. The constituents of that will be soil, dust, silica, salts, pollen, and the rubber, whereas less than 2.5 micron size, mostly from automobiles, and they will have the sulfates, nitrates, ammonia, carbon, lead, and the lead will be added as a catalyst. So organics. Now lead-free fuels are coming, and but that is the some areas it may be still lead is allowed, and so one has to take into consideration. So these are the constants which are available, will be present in the particulate matter, and if they are inhaled, and particularly the particulate matter 2.5, so they cause serious carcinogenic problems, and uh, which you have to mainly responsible for the various health problems associated with this. Coming to the, when I'm in Hyderabad, joined to you, we analyzed the particulate matter in the Hyderabad. So you can see a number of metals are present in this particulate matter, and which cause a number of deleterious effects to the health of the people. And so we also analyzed different parts. Each area, there is slight difference between the constraints. It only gives us how we should be careful about these particulate matter, because they contain. So there are two aspects so that we have to be worried about the particulate matter. Once they go inside, they, because their organic nature, because they will be with the hydrocarbons, so they directly go into the blood. The second one is, so they offer as a catalyst, because they are metallic surfaces and a small area, small size. There will be a lot of surface area will be there, and surface electrons will be there, so which make them more active. So they react with all the cell biology, and cause all damages to the cell. So these things one has to be careful, particularly when you are dealing with particulate matter. And so you can see some of the slide, how the lungs will be affected when the particulate matter goes into the, when you inhale, particularly less than 2.5 micron size. So they'll settle here, and not only the metals are toxic, they are good absorbers of toxic gases present in the atmosphere. So they slowly release those gases also. So make the decrease the elasticity of the lungs, and so the pumping capacity, just like the coronavirus is also shrinking the elasticity of the lungs. These will slowly the particulate pollutants will do that. And emphysema cases results from defective gene and that reduce the elasticity of the air sacs. And so these are the typical lung of a patient who is affected with air pollution. So similarly, carbon monoxide is one of the pollutant mainly released in automobiles. And carbon monoxide is reacts with your hemoglobin, and carboxyhemoglobin forms and decreases its oxygen carrying capacity of the hemoglobin and causes these are the emission source of carbon monoxide. So motor vehicles, aircrafts, and rails and industrial process, and in all these things the carbon monoxide will be emitted, but its residence time is very less. So we need not worry for a long time. It whatever happens, it happens in a short time. So exposure should be, if it is a closed environment, the carbon monoxide is released, one has to be more worried. And so these are the levels in which different health problems are likely to come. And so the one has to be, particularly this happens more in the carbon dioxide is released in a closed environment, the problem will be more severe. And another thing is lead, I told you. So lead is added in most of the some of the petrols and also diesel as a catalyst. And so this lead, when the diesel is burned or petrol is burned containing lead, so they will be going to the atmosphere and again released as a PM 2.5. So when you inhale, they settle at the bones and causing bone cancer and all bone problems. And so these also, many countries have banned lead, and I think India also followed. Now I think in India we have banned lead fuels, and may not be the problem now, but earlier it is the problem. And other air pollutant is particularly photochemical smoke. When the pollutants like when automobiles emit the oxides of nitrogen, they react with atmospheric oxygen to produce NO2 will become NO, and O2 will become O3. And the resulting a formation of O3 and atomic oxygen. This atomic oxygen again releases with reacts with molecular oxygen to produce ozone. And so like that, this is a chain process. And in this process, these react with hydrocarbons, polycyclic aromatic hydrocarbons. They form the corresponding nitrogen compounds, which are highly toxic. And with which, and all these things, you need some modeling studies. Sometimes you may not be able to do in a direct only monitoring. You need to understand. And for example, this is the situation. For example, when the traffic intensity increases, initially oxides of nitrogen, NO2 will be emitted, and the hydrocarbons will be emitted, and hydrocarbons will be emitted. These react to produce NO, and then the aldehydes and ozone. So these are the real culprits. So initially, when the starting, there may not be toxic compounds. After the traffic ends, intensity decreases. So in the evening, so for example, you see morning 6 to 12, there is intensity of traffic, and these oxides of nitrogen, NO and NO2 and hydrocarbons, there is increase. And after some time, they are converted into toxic aldehydes, ozone and ponds, which are the real problem. So countries or cities where there is a lot of moisture, sunlight, and traffic intensity is there. So this is a severe problem. And when ozone exceeds certain level, people are advised to sit in the houses. They are not, particularly children and women, are not advised to come out. And this already happened in cities like Los Angeles and other big cities. and is also coming, same problem coming in Delhi. And so this is going to happen because we also have plenty of sunlight, and Vizag is also potential candidate for ozone air pollution. And so here, these are the adverse effects of photochemical smog. We susceptible for respiratory and cardiac difficulties, and advanced bronchial asthma, chronic bronchitis, and pulmonary emphysema are the health problems that are going to come. And coming to air quality status in India, I have some data to share. Between 2001 to 2010, in the 5 major cities were done, were rather another data is there, where the respirable suspended particulate matter is above the accepted level, whereas the SOx is less than the acceptable level, whereas the NO2 is very high. So these blue one is a World Health Organization standard. Most of the cities are crossing this value, and so one has to take into consideration. So this how you can see already our metro cities are have a severe air pollution problem, which need already strategies are there implementing, and it is not a one-day problem. There needs a continuous study and a continuous modeling study, and so where the education institutes can play a vital role. Coming to air quality building plan for any city. So these are the essential things. We need a air quality monitoring. Earlier it is not there. Every universities or researchers who are going to there, they have to establish in consultation with the local pollution control board, the monitoring stations. Now the central control pollution control board has started the continuous monitoring in a number of cities, and the data is available as I have shown you for Visakhapatnam and Vijayawada. For every city they have done, and the data is available, so the researchers can use that. And you can also have a emergent inventory. Sometimes you need not have the monitoring data, or may not have the data also because of the expenditure involved. If you know the what are the source of pollution, you can also uh, rather prepare a emission inventory, how much is going to come from a transportation corridor with this kind of number of buses or cars, and or so we call is a line source or a industry which is going to emit. We know the if you know the strength of some details coming from the furnace, we can also tell calculate how much pollutant sulfur dioxide and PM2.5 are coming, and we can model it and then put that to the atmospheric conditions and develop a GIS based decision support system. And based on that, so we can do the air quality modeling. There are a number of modeling tools are available, and then develop a control strategy, and then for a clean air. So plan for the clean air. So this should be the model for building up a air quality plan. And so for this only, I'm just want to share what we have done in JNTU Hyderabad, and what we have done in Jackson State University, USA, Mississippi. And so what are the results, and so what kind of strategies we can still adopt for the present situation. And so we have established a online monitoring system which consists of a sensors, meteorological monitoring system, statistical numerical models for transport and dispersion of studies, and presentation of risk assessment module. These are the 5 components we have in our studies. And So this is, I think some of you may be knowing about Hyderabad. So this is a Panjagutta police station, which is a very intense traffic corridor, center point of that. There we have established a monitoring station, and the automatic station, this particular matter, automatically they will be collected every 1 hourly data. It will transmit to the website, and meteorological parameters, wind direction, and humidity, temperature, and atmospheric pressure, and also the NOx, SOx values. For all these things, we have put sensors. And this is a one typical system. They want to multiply it. So they've asked us to develop this. And at that time, we used to struggle hard because there is a problem, big problem in if you want to estimate something, you need standards, and standards, getting standards of SOx, NOx is we used to import from British chemical standards. They will be only stable only for 1 month. Next month again you have to go for that. So they are very expensive. So these are all the problems in actual experimentation, and so these are the things which uh, we have. So this is a particulate matter module. This is one is contains a number of sensors, and is a analytical computation system, and these so this system, control system, contains a main microcontroller board where all the sensors are hooked up, and there will be a display here, and these are all the meteorological parameters, these are all the pollution parameters, sensors. All these things will be directly displayed to the website. And it's not that easy at those times. That is, I'm talking about 1995 to 2000. And so there's a lot of computation aspects are there. So sending them directly to the website in those lines continuously, and 3 to 4 students, PhD students, used to work on that, and we developed a huge data. And I think all of you know about this air quality index. I just put one thing on. So this, whatever pollutants you are measuring, so for each, the actual value by standard, like that will, how many values you are taking, you divide by number. So if there are 3 pollutants, you divide by 1 by 3 into 100. So that gives the index value. So that index value will put it whether it is a allowable or green, or this is around 200 is this 150 to 200 is red, and up to orange you can allow. About this you have to take corrective steps and all that, which you can see that. And air pollution modeling products, we have used a community multi-scale modeling, the sparse matrix operator modeling. This is a 1 to 10 meters to 1 kilometer square meter area. Here we don't take into consideration the meteorological parameter. We assume the same in throughout the grid, and we commute the pollution coming in a box for coming from one area to the other area, depending upon the speed, temperature at which they are released and all that. And this is a smoke is a based on the source emission. So we use only various sources, their strengths, and from that we use. We don't measure anything here. Only we take some kind of rather, for example, this kind of line source emits this kind amount of their standard emission indexes. We use that and calculate the emission intensity of any source, either a line source or an industrial source, and all the source we identify in an area and then develop the model. So meteorology model is because the pollutants are moving along with the wind direction, wind speed, and also in a depending upon the humidity, temperature, and all that. So if you want a very fine, precise modeling, you have to involve the meteorology. And this is a package analysis, a visualization. So you want to have the visual maps, and this PAVE will give you. And weather research forecast model is also latest model in which we have worked. Is a chemistry model, is integrates the weather data into the pollution movement of the pollutant and gives a direct GIS display. This is the model on which we have worked in when I'm in US, particularly in Jackson State University. And so coming to the Hyderabad situation, we have developed a rather land use, land cover parameters and of the Hyderabad at that time. And then on those maps, we have overlaid the pollution maps so that which area is going to be affected. So this land use, land cover gives what are the residential areas, what are the hospitals, what are the parks. And so we can see based on that, to overlay pollution maps on this, we know which population is affected or which population is safe for the pollution. So you can see here a typical data I'm showing you, the respirable particulate matter, how it is varying. This is when on a rainy day. So, hello?
Shivashankar, please mute. Yeah, you can proceed, sir. I think someone.
Can I continue?
Yes, sir. Please continue, sir. Someone has to disturb. No problem. They're locked. They're unmuted. Yeah, they're muted. Okay, you continue, sir. Sorry.
Okay. So,
please continue. Yeah.
How many minute time? How much time I have to?
So still you have more than 5 minutes, sir. More than 5 to 6 minutes. No problem. Sir, no problem, sir. It takes, sir. Just continue, sir.
Okay.
Sir, no problem.
So on a rainy day, this is how the pollution has come down, particulate matter, and you can see how the inversion day, the pollution has come up, and we can. So this you have to present in different formats so that people can easily understand, and you will have a better view. And so frequency of distribution in a day, which day it is more, and why it is more, because is it more a big event is there, or the traffic is more, we have to relate, and you can explain, you have to explain with that. And this is also again a typical heavy metal concentration in the PM10 at Panjagutta area. And you can see all the heavy metals are present in different concentrations. And so this is the main culprits for all creating all health problems. And so here pollution, how is changing in inversion day. I think most of you may be knowing about the inversion. Normally, temperature decreases with altitude, but in some times there will be a increase in temperature. So if there is a decrease in temperature, there will be a movement, horizontal, latitude, vertical movement of the plume, and that will be disturbed if there is a inversion. So they'll come back, the pollutants will come back to the ground. So there will be a built-up of pollutants, and which you can see here. So this is how you can, this is the standard, and different times how the pollutant is changing. You can also map them. So these are all the different techniques to display your data so that you will get of course, one technique to write your papers, research papers more attractively. And so also you can decision makers, you can show very easily these are the things happening and all that. And you can see here the traffic intensity and particulate matter. So this is how it is happening. And so with there is a correspondence with the traffic intensity, and we can various pollutants we can explain how they are coming, and how they are changing into secondary pollutants, and all that. So this is regarding the heavy metals present in different sites in Hyderabad, for each site. We have given different colors for each metal and how they are varying values are given. So you can plot them so that you can put a huge data, a small display, so that you can easily explain things. And based on this data, we have prepared maps, GIS maps, where the pollutants like RSPM and this is these RSPM levels, how they are varying the total suspended particulate matter and respirable suspended particulate matter, how it is varying, and the red area is more prone for health problems. If there are any residential areas in that area, so you must also check the health problems for the residents there and relate to the pollution, so that natural strategies can be developed. And similarly, the particulate, you have the values for carbon monoxide, sulfur dioxide, and nitrogen oxide, and values in a day, how they are changing, and you can map them. And the same thing, you can also use the spatial maps, prepare the maps, these things. And these not a one-day business. So continuously you have to prepare, sometimes one day average, weekly average, annual average, and these need to be completely produced and made a thorough, because pollution, any pollution, whether it is a water pollution, air pollution, or any pollution, one measurement is a useless measurement. It doesn't signify anything. So you must know the trend, how it is changing, and over a period of time, over seasons, over in a day or over a week. So that is very important than a single value, and which that may be an accident or a aberration or something like that. So we don't consider single values. We have to consider, when you want to assess the pollution situation, you need a trend over seasons and all that. And the sulfur dioxide values, and so this is the, based on all these parameters taken into consideration, we have prepared the air quality index map for the area. And so these are the red areas are having higher values, and so we have to take care of the health problem, what is they're facing. So is there any link for the air quality and the health problem suffering? So then, so necessary steps, how to prevent. So we cannot take in a 1 week time area or one day value. So over a period of 3 seasons, we have to study. Then only, because if you want to relocate people, it is a big decision. So you can't take decisions on 1 day or 1 week data. So we have to build up the data and report these areas under stress. And so either you are changing the transportation routes, something we can develop strategies for control. So this is the health risk assessment one. So this is a methodology, and so selected population, weather information, and also real-time pollution, and representative monitoring also done, formulation of cumulative exposure. So inhalation transfer coefficient, there will be, so whatever there may be pollution here, everything will not go in directly to the people. So to what extent will go to the people? There are models, that what we call inhalation transfer coefficient models, and those models, based on that, how much, if it is 100 ppm a year, how much it is going to the people, and how they are absorbing, what is their effect and all that. So all these things is a framework. Of course, to tell the truth, we could not do much on this side, because these hospital data and all these things are there. Of course, by that time I left to US, and we did a lot of work on establishment of monitoring systems, development of air quality maps, and we have handed over to the AP Pollution Control Board at that time. And this is the World Bank project I have handled when I'm in JNT Hyderabad. And coming into the Jackson State University, And as I
Sir,
told
actually,
you,
another, sorry to disturb you, sir, another 3 more minutes or maximum 5 minutes, sir. Almost
yeah, I'll
10:28.
complete it.
Yeah, thank you, sir. Thank you.
So this is also again a development of decision support systems, and uh, uh, so this uh, involves a huge computation modeling. So where the global scale modeling outputs will be downscaled to the continent scale, regional scale, and local scale and urban scale. That means 1,000 square kilometer range to 0 to 1 meter scale downscaling. It involves a lot of intense computation models, and then prepare the integrate with the air pollution values and develop GS-based data support decision support systems. And I just quickly go through that. And this is the air quality decision support system where we need um, distance, time, meteorology, species of interest, concentration, objects, and multi-criterion overlay of GS, and all these things we require. And for each um, area, because entire Gulf Coast is in our study, so we have simulated the meteorological systems for the entire Gulf Coast, and also the land use, land cover data. And then, so this is I just skip because they may be high intensity, this one. And so we prepare a number of grids of different scale, and from each scale we downscale it from higher to lower, and then to a area of study. And then we have used the weather research forecast chemistry model, where you will get the 0 to 10 meter scale area pollution level in a spatial format, and we can prepare them. And in fact, we have prepared the maps. And the other thing is, this is one important thing I would like to highlight. In Gulf Coast, there are 7 thermal power plants, and these 7 thermal power plants are releasing pollutants. And our task is, there is a Gulf Coast is a highly biosensitive area, and we were asked to estimate how much PM 2.5, how much SO2, how much NOx is coming to this area by each power plant. We know the strength at which they are releasing, and the temperature at which they are releasing, the height at which they are releasing. So at a given time, we must, once we, there are some monitoring stations in the Gulf Coast. So when we have got some value, how much it is coming from the each thermal power plant, we have to assimilate, assess, and speciate, so that view maps, so that each power plant will be charged accordingly for the pollution load there, giving to the sensitive area. So this is the task we have successfully completed, and we are part of that consortium of the Gulf Coast power plant systems. And by using this high split pollution model, and then air quality health risk assessment studies for the entire Gulf Coast. And so there are 6 universities involved, whereas we are working on the Mississippi area, whereas other universities are South Carolina, North Carolina, all other universities are have taken this one. We integrate all the data. And this is a model simulated ozone values, NO2, NO, and ozone values, and compared with the or rather transport intensity, and lay down the on the Jackson city land use, land cover area, and prepared the spatial maps for the coverage of the urban air quality of the Jackson for a particular period for the ozone values, different areas which are going to are affected, and prepared the decision support systems for them, so that the transportation correction intensity was done. So they have changed the areas, the transportation sectors, some of the routes, so that the ozone values will come under control. So these are some of the conclusions where for that program. And because so these are some of the research papers. I think some of you already know the books I have published. Anyway, I'm sorry. I'm able to thank you for your kind attention.
Thank you, sir.
And this is what I have done in the last 30 years in a small this one.
Thank you, sir, for your wonderful talk, and it's really grateful to listen your talk. It's really valuable message to all of us, to the young generation. So now, actually, the session is open for Q&A, question answer. All the
Yeah.
participants, if you have any questions, please unmute by yourself and ask the questions, and please mute by yourself, because when sir is giving the answer, so everyone is able to listen very clearly in the crystal clear way. Thank you. The session is open for Q&A. Dr. Shivashankar, any questions, sir? Okay, I have few questions I have noted from the audience, and for myself also I have questions. So you have very clearly mentioned the modeling plays an important role. So so could you tell me that any of the specific software it would be useful for the audience as well as the students for their research on their to do some of the further continuation of the research on this particular environmental science area? Any specific software for modeling, sir?
Yeah, the modeling all depends upon what is your target. So what pollutant you want to monitor, and what is your actual usage. So the final object of your modeling is, so is it to go for a decision support system on GIS platform, or simply understand how it is moving. So there are source modeling, that what like smoke, where if you have the what are the various sources of the pollutants, you can give some value, or there are some rules to get a value, and use that and develop the total source strength, and then uh, use a box model, in the sense that is a very old model, box model, and rough model, in the sense you are not considering any meteorological parameters. And so you are considering you are assuming everything is constant in that, and how it is moving the pollutant, so coming, entering into a box, and then spreading into there, and what are the areas you will do that. So that is a coarse way of doing things. But if you want a highly precise way of doing things, weather research forecast model, then that chemistry is there. So you integrate the meteorological parameters, and also the movement of the pollutants, their dispersion, their everything, the character and all that, and then develop a spatial map. And if you have some interest, this WARF model, though is available in the open domain, you need a huge computational infrastructure. If somebody is interested, I give one address. One of my student is working in Kalpakam. He has all the infrastructure. You can collaborate with him. So you give the data, or you go there, he will arrange for you the for modeling, and he will also train you. And yeah, he will come and give some lectures if you want. And he worked with me in Jackson State. And so he has the infrastructure. That is what I'm going to tell. Working infrastructure. Modeling, you may have a good computation facility, but you have to keep that, because all these parameters you have to keep in the store, and the computation aspects, different layers you have to extract and integrate with the model. So that requires a lot of computational aspects.
Good.
So that is what I suggest. But another
Thank you.
thing is, one suggestion for all of you is, don't any research, whether it is air pollution research, any research, don't try to take any routine problem. Try to take some innovative ideas, and try how difficult it may be now, because you have in a different world where everything is available, information available, you can coordinate, collaborate with so many people. Try to take more useful, simply instead of doing a routine problem and getting some papers, it doesn't serve any purpose. Take some innovative ideas and try to do, work out them. Maybe slightly, there may be initial barriers, but don't worry, try to solve them. So here also this lot of you have some computational problems will be there for any institute here, and you can definitely collaborate with national institutes. There is in Pune, there is one international tropical climate institute is there. You can also collaborate them. All these WARF and all that, they continuously run. And so you can give the problem, you can give the data, and your need, what is the area you want to study, what is the purpose of that, so what is your object, all these things you have crystal clear. So you have to write the grid in which you want to study, then you can assimilate and basically learn the computation aspects. And that is the thing.
Thank you, sir, for your wonderful information on this regard. These questions, so many questions are there due to the time limitations. I will write it down in personally the mail. Then we will discuss. And
Yeah,
sure.
you can write down and I'll respond.
Yes.
And though I'm in US, so I can give some people who are working in this field, who are my students or like that, so that you can, somebody interested, they can collaborate, and you can have a joint programs or something like that. They will come and all that.
Sure, sir. Sure, sir. Thank you so much, sir. Now I request Dr. Sengupta to give the vote of thanks. And at the same time, I request Dr. Ravi Kumar to float the feedback in the our Zoom as well as the YouTube. Dr. Sengupta, madam, please.
Yeah, sure. So
So, ma'am, 1 second, madam. Desikan sir.
Sir, please proceed.
Feedback I already sent through mail to everyone.
Okay, sure.
I request the, Anil sir, please transfer host to me. Process further.
Sir, Professor Anjanelu sir, please transfer the host to Dr. Ravi Kumar because we
no, Sri Ranganath, sir. Name actually Sri Ranganath.
Oh, Sri Ranganath.
You want the PPT be transferred?
No, sir. Actually, the host host. We made you as a host.
Okay.
Transfer. Yeah.
Name actually Sri Ranganath.
Oh, okay. Transfer to Sri Ranganath. Utpala Sri Ranganath.
Yes, sir.
Transfer you make him as a host. Utpala Sri Ranganath.
Okay.
Yeah, thank you, sir.
Okay.
Sengupta madam, please proceed.
Okay. So coming towards a conclusion of this webinar, on behalf of the organizing committee, I would like to thank Professor Anjanelu Iramelli for his enlightening talk on a very important environmental concern of today's world. I would like to thank him once again for keeping our request and delivering this lecture for us at VFSTR and especially for our students. Thank you, sir.
So, coming towards the conclusion of this webinar, on behalf of the organizing committee, I would like to thank
Okay, thank you so much, sir, for joining, and I also thank Dr. Shivashankar for this wonderful coordination. Thank you, sir, Dr. Shivashankar. Thank you, sir, Anjanelu sir, also. Thank you so much. See you again. Yeah, all of you can leave. Yeah, please.
Thank you, sir. Sir, Anil, sir, thank you, sir.
Ravi Kumar, sir, you can close this session. Yeah.